Now I shall discuss about subset selection in regression using R. Now, as I have already mentioned in my earlier videos, subset selection is not a very popular technique anymore in view of the fact that you have better techniques like ridge regression or lasso. But still, I will just explain it. For this, you will need a package that you need to install called lips. So I have already installed it and I am loading it. Now I will use a data set about the states of the United States, some data set. I do not care what it is, I am just using something which a moderate number of regressors. I need that in order to explain the idea. So I will load the data. It's already part of R, and I create my state data from the state.x77. So this data state that contains lots of different data. I am picking up one of them, state x77, and I am giving it some row names, which are state abbreviation of the state. So if you want to take a look at that, let me just show you the name. State data, population, income, illiteracy, life expectancy. This is our output response. Murder, how many murders have been committed, high school graduate numbers, frost, and total area. So if I take a look at the data, this is the data. So for each of these states, you have all these observations. So we have got 8 measurements per state. The dimension of the data is 50 by 8. So 8 measurements and 50 states. Okay. So what I want to do is I want to regress life expectancy on the remaining 7. Data is state data. So this much is pretty much like the LM function. However, I want to perform all subsets regression, so I want to go through all the 2 to the power 7 many subsets and try to pick up the best. Now, the way it is done is not exactly giving you the best. What it will do is it will pick up the best subset of size 1, the best subset of size 2, in this way the best subset of size 7. By the way, there is only one subset of size 7, so it will give you that. So let's do that, and it's pretty fast. So it finished all those things and has done a very good job. Now, weird thing is, if you try to look up what is inside B, you will not be able to make any sense of it. You always have to look at it through the function summary. So summary of B will only make sense. B directly will not make any sense at all. So I will do that. So I will create the summary. Now from the summary, we can try to see what that is. So I will hit RS, and again it gives you something pretty weak. You do not understand what that is. So let's look at RS which. So RS has various pieces of information in it. When you see this, you will see that what are the various things. It says 1. That means it is giving you the best subset of size 1. And here the intercept term is always present, and everything is false except for murder. That is, if you are trying to predict life expectancy and you want to keep only one regressor, keep murder, which is very natural, because if there are too many murders, naturally life expectancy comes down. So that is the most important thing. If you have to use only one, use murder. Then comes 2, which means what is the best subset if you are using 2 regressors. Then murder remains true, of course, and education comes next. How many high school graduates there are? Maybe the more you study in a school, your life expectancy possibly goes down. You have to listen to all those boring lectures. And then comes 3. Now true, true, true. Now you can see here that the subset is growing. So if something is true, it remains true all throughout. Now that is not necessarily always the case, because here I am working with all possible subsets. It may happen that something is important, but if you allow 2 variables, then possibly some 2 other variables will be important. But in most cases, you will see that the things are growing. And if you want 4, then you will have population and murder and HS grad and frost. And finally, if you go up to 7, then naturally everything you have to include. So this is how you get all this stuff. And remember, they have just used a criterion like BIC. So they are basically looking at all the fits and then choosing the one with the smallest BIC out of that entire class of models. Now, you can change this criterion from BIC to AIC to whatever other things. You can look up the help to see how it is done. So this is just a way. It is really not fitting all the individual models. It is doing something more clever. It is giving you all the different subsets. It is basically telling you which subset is good or bad. Once you choose upon that subset, then you can carry out your usual LM method to get the actual coefficients.